This one, you need to find the longest chain. Which one is my longest chain?
Miss, can we just do the word from?
Can we do this one first and then we'll move to that one?
Is the four.
Okay, so I have this one. Do you all agree that this is my longest chain?
Yes.
Okay, so what's coming out of that? What's branching out? Two methyls. Okay, which side do I start to count by? Number from the closest. And which side is the closest? From the right side. So this is 1, 2, 3, 4. Okay? So the ending is going to be what?
It's going to be 2.
What's the ending? Well, meaning my suffix? It's going to be butane. And in the prefix, at what position did I first start to see the side chains or the branches? 2. But how many of them did I have? 2. So I have to indicate how many branches I had in that. So this is why you have 2, 2 to tell me that at position 2 I have 2 branches. And how many methyls did I have? In this case, they're both the same. But I need to count them as well. So 2 methyls, 2 means di. And then they are methyl butane. Once you understand this, then you'll know how to read this. Okay? Alright, now this is if I have a structure and I need to do the name. If I have the name, you start off with the suffix and then you add in the branches. Okay? So Mariam, what is the suffix here?
Try.
What's the suffix here?
Butane.
Butane. Butane has how many carbons?
2. Wait.
Miss, can I check if I did 2, 2 or 3, 3?
4.
4. So I draw that first. Don't draw in the hydrogens at the beginning, just the carbons. Okay? So now I have 4 carbons. At what position or positions do I see the side chains? 2 and 3. At 2, I can go either way because it's a butane. I can start number 1, 2 or 1, 2. Okay? What do I have at position 2?
2.
I have 2 what?
Try.
I have a methyl. The tri tells me that there's 3 of them. Okay? So at position 2, I have 2 methyls. And what else do I have? At position 3.
You have position 3.
Okay? So that means the rest of this molecule is CH3, CH3, and then I have a hydrogen here. And if I wanted to read it from the structure to the name, I can clearly see that at position 2, I have 2 methyl groups. And at position 3, I have a third one. So that's why you have the tri, because there's 3 of the methyls. Okay, now you tell me this one.
It's first pentane, so we do 5 chlorines.
Yep.
And then you see that on the third one, there is a methyl.
How many methyls do I see?
3. I mean 2.
2, because there's di. And the rest would be what?
Just add hydrogen. So
Excellent. CH3, CH3, this will be CH2, and this would be CH2, and that's it. Does that make sense?
Yes.
Any questions?
Yes. Why is it CH2 in that second unit?
Because I've got 2 bonds, okay? I need 2 more. So these are going to be the 2 hydrogens. I just did the condensed formula, but that's fine. You can add the hydrogens like that. Does that make sense? Just really important that the last carbon is always going to be a CH3 in an alkane. Okay, and this is important when you're starting to draw isomers. That's why when you're changing the shape, changing the structure, you never add in the end. You change in the middle. Okay, because the middle is basically where you're going to condense it more and make more branches, etc. Okay?
And this when it says acid, not